Q hat is 1 minus that. N is my sample size. That's the minus, and then I always just kind of go in. This sounds like it's picky, but I promise you from the math perspective, it's not. Your interval needs to go in increasing order, so it needs to be the smaller than the bigger, okay? So just kind of think that through, right? Does everybody see are we good with like kind of where each number came from? Again, and when you have that full out formula, you're plugging in, okay? All right. Now, what is this? This was estimating the percentages in Columbus that are actually support Ohio State, okay? So if I'm going to ask you to construct, and then I'm also going to ask you to interpret. So this next part is how I would interpret this interval. The population proportion of Columbus residents who support OSU is between 0.857 and 0.895. Because what we're estimating is not the sample, but again, you want to communicate that what this is a guess at where the population is. So let's say you're walking down the street and you run into somebody from OSU and they're like, yeah, man, OSU's so great. More than 95% of Columbus residents are OSU fans. You would say that isn't true. Everybody good? So in between here is all the possible different percentages based off of our sample. Everybody good? All right. If I asked you what was my margin of error here? Well, my best guess is 0.876. I did 0.876 plus or minus some margin of error, and that resulted in the 0.857 and the 0.895. So the quickest way I think to get there is I might say that 0.876 minus 0.857. 0.19. Another way I could get there, that plus or minus is really just this formula. Either way, both would give us about 0.019. Okay? It's a good place to stop. So if I were to, so here we have 9 out of 30 students said that they talk to themselves or studying. Do you guys ever like you say talk out loud while you study? I do that all the time whenever I'm trying to learn something new, because I do better if I can hear it and see it at the same time, right? So it's the idea of you're giving yourself something to hear. Okay? So in this particular case, so what would, if I say 9 out of 13 or 9 out of 30 people talk to themselves while they're studying, what we're trying to get to is the percent or the proportion of all students who talk to themselves. And what we have is the values from a sample. Right, so my point estimate is always going to be the value from my sample. It's my best guess. This is what we're trying to estimate. We don't know the proportion of all students everywhere, right? We only have these 30 students, and if I wanted to turn those into a proportion, I would call that proportion a p-hat, which is 9 out of 30, which I believe to be 0.3. All right, so now let's say, next we have to do is we have to create a confidence interval. And what I'm going to do is I'm going to think through, I don't remember how to do this, so I'm going to go to my formula sheet. I, in fact, have it right here. And I have a formula on it that says p-hat, the confidence interval is p-hat plus or minus z times the square root of p-hat q-hat over n. Okay? So let's go through and figure out what do I need to fill in for each of those things. Certainly we already did.
Interruption. Any students attending and participating in the wrestling district regional match, please go ahead and come down to the office. Thank you.
So we just set up top, p-hat is 0.3 plus or minus. Okay, do you guys remember from yesterday, how we calculated z? We're going to draw a picture. If it's z, we know that the mean is 0, standard deviation is 1, 90% confident means I'm doing the middle 90. If the middle is 90, each tail needs to be half of the remaining 10%, so in this case, 5%. And can somebody throw that into the calculator and tell me, how do I throw that in the calculator again? What operation do I pick? Inverse norm? We should get 1.645. Okay, so this becomes 1.645 times p-hat is 0.3, we already said. If p-hat is 0.3, y'all, what is q-hat? .7, right? Remember, like, percentage of success and percentage of failure. So these two, the p-hat and the q-hat, will always add up to 1. Okay? And what do I put in for n? I'm sorry? 30. All right, so then we just throw that in the calculator. Do you need a copy? Do you need another copy?
Yeah.
I can send you a PDF. I'll email it to you. But you need to email me reminding me because there's no way I'm going to remember. All right. Da-da-da-da-da. Everybody good? All right. I do want to show you, there's an operation in the calculator that does this a little bit more quickly. Okay? So we've never used this menu before. We're going to go ahead and hit stat. And what I want you to do is if you look at the stat, we've always been in edit or calc. like you to go over to the tests at the top there. And you'll see a whole bunch of things. Now, you guys can't see as much as mine because mine is portrait style and yours is landscape, right? Okay, but if you scroll down, essentially what we're doing is a z interval. I know it's a z interval because this is a z for a proportion. So if you scroll down, do you guys see how option A says 1 prop z int? What that's saying is I'm doing a z interval for one proportion. So go down and hit A. 4 or 5.
Okay, sorry.
All right. X and N are the two values that give me my p hat. Okay? So you're going to say this is 9. You're going to put 9 in for X. You're going to put 30 in for N. And you're going to tell it your confidence level, which is 0.9. For the confidence level, you can't do 90. It has to be in between 0 and 1. Is everybody good? I hit enter. I get the exact same interval. Everybody see it? Okay, so this, by plugging into here, it does this whole formula for you. Does that make sense? Everybody good? All right. Now, so I don't care if you get your interval from here versus if you get your interval from here. There's other ways I can ask you to make sure you understand the rest of it, okay? All right. Now, we've done the construct, we haven't done the interpret, okay? So the interpret would be the population proportion of all students who talk to themselves while studying. Is between 0.162 and 0.438. Now, I would not call this a very informative interval because I think that, and when I say that because my margin of error here is very big, okay? Now, how do I find that margin of error? Well, if I find it using this equation, my margin of error is just this whole expression, right? It's everything that comes after the plus or minus. Is everybody good? So I could find it by doing 1.645 times the square root of 0.3 times 0.7 over 30. Like I could just do that. But if I never even filled out that formula, my other way of saying how do I find my margin of error is I can do one of two separate problems. I could either do 0.438 minus 0.3 or 0.3 minus 0.162. So picture-wise, our estimate is 0.3, and then we added our margin of error, and we ended up with 0.438. Or my 0.3, I subtracted my margin of error to 0.3, and I ended up with, you guys see what I'm saying? So it's 0.3 should be the midpoint of my interval. Should be the exact middle. And then how far is the exact middle to either side? One other option I could do is I could say, well, how far apart are these two? Because I know the entire width of my interval is 2 margins of error. So I could find the distance between my interval and divide by 2. All different ways to get to that my margin of error is 0.138. Everybody good? Okay, let's turn the page. All right, now, when we go back, that previous question had a margin of error that was like 14%. If I'm trying to estimate a percentage, having a margin of error of 14%, so somewhere a range that's 30% wide, is pretty crazy, right? Like, that's not very useful. So a lot of times what we do is we say, all right, we want to be 95% confident. That means our interval is going to be right for 95% of the different samples, possible samples. But I also want my margin of error to be within a certain range so that my estimate is as accurate as I want it to be. And so there's two things that influence our margin of error: how confident we want to be and our sample size. So we can control our sample size. So if I take that margin of error formula, which essentially is z times the square root of p hat q hat over n, okay? If I work this backwards to find n, I get this equation. This equation is on your formula sheet. Okay? So if I'm asking you to find your sample size within a given margin of error, you want to use the formula that has the n by itself, because n is the sample size. You guys catch what I'm saying here? Okay? So as I look at this next one, it says determine the sample size necessary. So the minute I see that, I'm saying find n. And if I want to find n, this is the formula on my formula sheet I want to pick. Okay? To construct 95% confidence interval within 3%. So when I see that within 3%, that tells me I want my margin of error to be 0.03. And last year it was estimated that 45%, so p hat, in this case we have a possible p hat, or a reasonable guess that p hat is 0.45. Okay. Does anybody remember what is the z that goes with a 95% confidence interval? If we don't remember, it's not a problem. We find it. But does anybody remember what it is? 1.96. It is 1.96. If I don't remember it, this would be my picture. Everybody good? All right, so now to find my sample size, just fill in everything I know. Z squared becomes 1.96 squared. P hat is 0.45. That makes Q hat 0.55. And my error, 0.03 squared.
Will these formulas be all on the formula sheet?
Everybody good? Now, I get that my sample size is 1,056.44. Now, I will not give full credit for this answer. Can somebody tell me why I would not give full credit for this answer? You can't have a partial sample size, right? Okay? And we want to minimize that margin of error, okay? So even though I look at this and I say, oh, that would round to 1,056, if I round down, it's possible that my margin of error is now 0.031 because larger sample size equals smaller. So in reality, our sample size isn't equal to, it's got to be greater than or equal to these values. Okay, because it's the larger sample sizes equal smaller margin of error. So when you're finding what is the necessary sample size, it needs to be a whole number because it's a number of people in a sample, okay? And you always round it up. Even if this was like 1056.01, it rounds up because if you round down, your margin of error just got wider, not smaller, not narrower. Okay? Are we good? All right. Now, as I look at this one, I gave you a lot less information in this problem. I gave you 95%, which can get us that Z is 1.96. I gave you within 4%, so that makes my error 0.04. But what didn't I give you in this case? I didn't give you a p-hat. Is everybody good? Okay. You always use, if you're not given that potential value for p-hat, you always use 0.5. The reason you use 0.5 is that's the widest margin of error that would happen based off of, that's the p-hat that gives the widest margin of error. If we're assuming from the beginning that we have the widest margin, then if p-hat's different from 0.5, that just means we'll still be under, okay? So when you're not given a value, you use 0.5. So this sample size would be 1.96 squared. So what would you put as your final answer for this one? N has to be greater than or equal to 601. Is everybody feeling good? Okay, so if I'm looking at, I'm going to let you work on homework for the rest of the class period. As I'm looking at the Unit 7 homework. The problems on the Unit 7 packet that you can do are problem number 2, 3, 6. Problems 2, 3, and 6 are the ones you guys would know how to do so far. Everybody good?